Good morning, friends. This is Abinaya, working as assistant professor in Department of Mathematics, Bishop Heber College, Trichy. Today, I am going to brief a introduction about edge coloring. What is edge coloring? Edge coloring is nothing but coloring the edges of the graph with adjacent edges should have the different colors with the condition that adjacent edges should have the different colors. Here is the definition of the edge coloring. An edge coloring of a graph is a coloring of the edges of such that adjacent edges receives different colors. As I told you earlier, adjacent edges should receive the different colors. That is, if any two edges have a common vertex means then that two edges are said to be adjacent edges. Why? Because it shares their endpoints. So that edge should be colored with different colors. That is the edge coloring. That is called the proper edge coloring. So afterwards, minimum edge coloring. Definition of minimum edge coloring. An edge coloring contains the smallest possible number of colors for a given graph is known as the minimum edge coloring. That is, the smallest possible number among the edge coloring is called the minimum edge coloring. Then afterwards, next we are moving to the edge chromatic number. Usually edge chromatic number is denoted by chi dash of G and it is defined as the minimum cardinality of the minimum edge coloring is called the edge chromatic number of the graph. That is, minimum colors needed to color the edges of the graph is called the edge chromatic number and it is usually denoted by chi dash of G. We all know that vertex coloring is a vertex chromatic number is denoted by chi of G. So next we are going to see one example. Here is an example. We all know that this is a complete graph with 4 vertices. Here there are 4 vertices and 6 edges. We have to color the edges. We have to color the edges since it is a complete graph. We know that if you take one vertex means then that vertex will be adjacent to all other 3 vertices, right? So that is called the complete graph. Here there are 4 vertices and 6 edges. We are going to color. So the minimum color needed to color the edges of K4 is 5. Why? Because see here 1 3, the edge 1 3 and 2 4 are distinct, that is non-adjacent edges, then that can be colored with the same color, right? So that can be colored with brown. So the minimum colors needed to color the edges of K4 is 5. So the edge chromatic number of K4 is 5 and the vertex chromatic number of K4 is 4. So here is then another example. So next example, we are going to see the next example. In this example, there are 6 vertices and 9 edges. So the minimum colors needed to color the edges of the graph is 4. Minimum colors needed to color the edges of the graph is 4. So therefore, the edge chromatic number chi dash of G is equal to 4. So the edge chromatic number chi dash of G is equal to 4. So dear friends, the edge coloring is the important topic in graph theory. There are plenty of applications in edge coloring. One of the important applications of the edge coloring is timetabling problem. The timetabling problem is nothing but using this edge coloring we can able to reduce the number of rooms used for number of classrooms used in the academic centers, either it may be school, colleges or anything. We can able to reduce the number of rooms by using this edge coloring. This is the one of the important applications of edge coloring. Thank you all.